7.5.1. Find the areas under the graph of A. Y equals 1 over x squared. B. Y equals 1 over roots of x in the intervals. First, x equal 1 to x equal s, where s greater than 1. X equal r to x equal 1, where 0 less than r less than 1. Answer. The function are ax to the power of minus 2 and bx to the power of minus half. So the simplest integrals are a minus x to the power of minus 1 equals minus 1 over x. First integral from 1 to s, 1 over x squared dx equals minus 1 over x evaluated from 1 to s equals 1 minus 1 over s. Integral from r to 1 over x squared dx equals minus 1 over x evaluated from r to 1 equals 1 over r minus 1. B. 2x to the power of half equals 2 roots of x. First, integral from 1 to s, 1 over roots of x dx equals 2 roots of x evaluated from 1 to s equals 2 roots of x minus 2. 2. Integral from r to 1 over roots of x dx equals 2 root of x evaluated from r to 1 equals 2 minus 2 root of r. The interesting feature of this result appears if you consider what happens in first if s becomes infinitely large, and in 2 if r comes indefinitely close to 0. Consider s first by taking a large enough value for s. You can make 1 minus 1 over s as close to 1 as you like, but it always remains less than 1. You can say that the integral a first tends to 1 as s tends to infinity. Written 1 as s infinity. A shorthand for this is integral from 1 to infinity 1 over x squared dx equals 1. This is called an infinity integral. However, 2 roots of s minus 2 can be made as large as you like by taking a large enough value for s. So the integral b first tends to infinity as s tends to infinity, or infinity as infinity. Since infinity is not a number, you cannot give a meaning to the symbol. Integral from 1 to infinity 1 over roots of x dx. In the case of r, the situation is reversed. The expression 2 minus 2 roots of r tends to as r tends to 0. So you can write integral from 0 to 1 over roots of x dx equals 2. Even though the integrand 1 over roots of x is not defined when x equals 0. This is called an improper integral. But in A2, 1 over r minus 1 tends to infinity as r tends to 0, so you cannot give a meaning to the symbol. integral from 0 to 1 over x squared dx, you can see from the graphs that, as you would expect, the case where the integrals are defined correspond to regions in which the graph is very close to one of the axes. You can then say the region has a finite area even though it is unbounded.